We welcome Professor Petteri Taalas to India Meteorological Department. And at the very outset, I would request Anoop to please briefly introduce Professor Petteri Taalas, and then I would request our DGM to welcome him.
Thank you so much, sir. Honorable Secretary MOS Dr. M. Ravichandran, DG IMD Dr. M. Mohapatra, Speaker for today's talk, Professor Petteri Taalas, colleagues and friends from IMD, participants both online and offline. Good afternoon and namaskar to all of you. I'm Dr. Anoop Misra from IMD New Delhi, and I'm delighted to get an opportunity to introduce our speaker for today's talk. We are honored to have Professor Petteri Taalas with us. Dr. Taalas specializes in climate change, disaster management, water resources, change management, efficiency improvements, and UN affairs. Born in 1961, Dr. Taalas holds a PhD in meteorology from University of Helsinki. His distinguished career spans both scientific research and leadership roles in atmospheric science. Before serving an 8-year term as Secretary General of WMO in Geneva, he was the Director General of Finnish Meteorological Institute for 11 years. He resumed this position on January 1st, 2024. And Finnish Meteorological Institute is a globally recognized research and service organization, leading in climate science, Arctic research, and space satellite activities in Finland. Professor Taalas has held numerous trusted positions in national and international organizations, including membership in the UN Secretary General's Climate Core Group, chairmanship of Board of European Meteorological Satellite Organization, vice chairmanship of EC Atmospheric Science Panel, and roles in IPCC, where he chaired Finland's National IPCC Committee. Additionally, he has been involved in academia, serving as chairman of the Board of University of Eastern Finland. And he has contributed to national government bodies such as Finnish Space Committee. His private sector engagements include positions on board of directors of Forum Energy Company and the advisory board of Value Food Program. Professor Taalas, as a key advisor to UN Secretary General Antonio Guterres, Professor Taalas led historic reform at WMO, modernizing its structure, partnerships, and global role as dominant voice on climate, disasters, and water science. His contributions have earned him numerous accolades, including European of the Year by Reader's Digest 2021, Expat of the Year, Finland Society 2019, Alumni of the Year, University of Helsinki in 2012, and Friend of the Year in 2022. I request all of you to join me in welcoming Professor Taalas.
Now, I would request our DGM to kindly welcome Professor Petteri Taalas by presenting a flower bouquet. Also request DGM to please welcome our Secretary, sir. And welcome to Dr. Antti from Finnish Meteorological Institute. Now I would request our DGM to say a few words in
respected Secretary, Minister of Earth Sciences, Dr. M. Ravichandran, Chief Guest of this function, Professor Petteri Taalas, Dr. Antti, Head of International Cooperation, Finnish Meteorological Institute, and the status of as we can see here, there is a presence of the experts and scientists, engineers from India Meteorological Department, Ministry of Earth Sciences. The people have joined online from various institutes within the country and outside also. So on behalf of India Meteorological Department and personal behalf and the Ministry of Earth Sciences, I extend a warm welcome to Professor Petteri Taalas. And especially we are obliged to Professor Taalas for agreeing to deliver a special lecture on activities of Finnish Meteorological Institute and the status of global climate. As all of us know, Professor Taalas has been the brain behind as the Secretary General of World Meteorological Organization to bring out the paradigm shift in activities of WMO. The entire framework of activities, the objective was changed under his leadership, and the process is continuing now. So thank you very much in bringing out the reforms with respect to the activities of WMO. As far as international cooperation is concerned, Finland and India Meteorological Department has been working together for a long time with very noble beginning in 2014. There has been memorandum of understanding, there has been joint work. So both the countries have benefited by understanding the various aspects of the Earth system, and especially with respect to the atmosphere and air quality. There has been development of modeling, apart from the process studies and applications. And finally, this cooperation has helped to the people to provide. Okay. So therefore, this success story has grown over the years. And at present, we have got 2 different models available from FMI. And we have also the joint team working towards the various process studies with respect to air quality. So as I was telling that there are certain issues which the humankind is confronted with in every country. But there are certain specific issues somewhere, so like in Delhi, we have got the air quality issues for which the specific developments are needed. And at that time, FMI has been working with IMD. So we can further improve our cooperation for better understanding of the various processes and to improve our monitoring and forecasting systems and early warning. For your kind information, Ministry of Earth Sciences issues air quality early warning systems. Apart from the FMI systems, also we have got some other systems. India Institute of Tropical Meteorology, National Center for Meteorological Forecasting, and IMD work together to provide the operational forecast on daily basis with respect to air quality. So as we were discussing a little earlier, there are various scopes to improve further, not only the air quality monitoring and early warning systems, but also to improve the spatial and temporal resolution of the products being generated with respect to air quality, being extended to other cities and towns in northern India. There are challenges with respect to understanding and precipitation of other severe weather events like precipitations, heavy precipitations in the Himalayan region, cryospheric studies, and the forest fires, and many others which we thought about, and the collaboration will go further with the support of the Ministry of Earth Sciences. Dr. M. Ravichandran, Secretary of Earth Sciences, has been a guiding force, I will say, in the ministry. With his leadership, all the components have come together, and there are the success stories wrought in the past few years with his leadership. So he is very supportive to new ideas and new initiatives which can address the requirement of the observational infrastructures, the modeling, the forecasting, and early warning, and its dissemination to the public and various stakeholders. So therefore, it is a very good opportunity where IMD and other organizations, Ministry of Earth Sciences, will work together with FMI under his leadership and enhance our activities and cooperations. So I thank Dr. Antti for continuously supporting and coordinating the international cooperation between India and the Finland, especially with respect to the various activities in Earth system sciences. So with this, I once again welcome Professor Petteri Taalas, Dr. Antti, for this symposium. I just want to mention here that India Meteorological Department completed 150 years. And this lecture series was commenced 1 year back, and that is continuing. And you are delivering today this talk in that regard, commemorating 150 years of India Meteorological Department. And this particular topic will be very much beneficial to the researchers, the students, the scientists and engineers participating in this program. And this knowledge base will enhance their capability. The capacity building will be certainly enhanced in this country to address all the existing problems and improve the solutions for early warning services and forecasts provided to the people. So thank you very much. And I will request Secretary Sir to speak a few words.
I think maybe we listen directly. We can go for his talk.
So this is the actually 36th lecture of this series. And now we request Professor Petteri Taalas to kindly deliver this lecture.
Should I speak from here or there?
Yeah,
Anyway,
you can speak here.
okay. So thanks for the opportunity to be here, and I have been a friend of India for the past decades, and have already more than 25 years of experience in collaborating with you, both with IMD and with Petteri, and more recently with IIT Madras in Chennai, where I was yesterday, and I have been very impressed to see what has been happening in India as a country. You are now a very advanced country, and I'm sure that this is not going to be the end of the progress in India, and what I see already yesterday in Madras, you have very high level science besides here at IMD and Petteri, but also there I was impressed of the quality of the work, and in general what kind of development is going on in India. And we have plenty of common interests with you concerning equality, climate change, and how to improve the early warning services. And I will show you briefly what FMI does, and finally I will tell what we know about the climate change in general. Next, please. My CV was already mentioned. I have been about the Director General, I have been scientist, and I have been dealing with the WMO issues, and also I have been Board of Directors member of Fortum Energy Company, which is the biggest energy company in Northern Europe, and they are also having some solar energy fleet here in India. Next, please. And at FMI, we are special meteorological service because we have also fairly strong science basis, and we are a little bit older than IMD. We were established only in 1838, and we have climate research. We are the biggest climate research unit in the country. We have also plenty of this atmospheric chemistry, climate change, air pollutant expertise, and then we deal with marine issues and also space and satellite observations besides the classical meteorological services and related infrastructure. And about 1/3 of our staff members, they have PhD level, and our annual budget is about 100 million euros. We are fairly strong on the European scale. Of course, your numbers are very different because you have such an extensive country, and of course in China it's even more. But we are one of the leading medium-sized met services in the world. Next, please. And we provide wide range of services for various customers, and in our case we have snow and ice on the ground up to 6 months a year, which is our special feature. But we are providing lots of services for emergency management authorities, for military purposes, private sector, and media, and we are also having commercial services. And at the moment, the big issue for us is use of artificial intelligence in the numerical weather prediction modeling. We are just training our models to use such means. also machine learning to develop impact-based forecasts for various customers and users is a big issue. Next, please. And for example, we have seen an increase of the rescue operations caused by severe weather, and that's what the whole world is at the moment facing, that we have seen an increase of such things. Of course, there's a year-to-year variability, but there's a clear trend also in that respect. Next, please. And as I said, transportation is our key customer, and we are providing aviation services, marine services, railroad services, and road services, and especially winter road maintenance is one of our big customers. Next, please. And then we provide also military services, and unfortunately, there's growing geopolitical tension in Europe at the moment, and that's why many West European countries are preparing. They're providing more services for military sector, and that's also our case. We are providing missile and drone type of services, which are new things for us. And next, please. And then we provide also these early warning disaster services for various Finnish customers, but also we are doing it globally. We are monitoring high impact tropical storms, earthquakes, volcanic eruptions, and various disasters worldwide from our operational service. Next, please. And then we can calculate the dispersion of various materials, radioactive releases, like this Fukushima case several years ago in Japan. We can calculate how the smoke from Californian fires is dispersed, volcanic ash dispersion, air pollutants, and also in the sea area we can calculate potential oil accident, oil dispersion. Next, please. And we have air quality models for various scales. We can do it for regional scale, for covering the whole Europe. We can do it for our country, but we can go to very small scales, so even individual streets to calculate how the air quality is dispersed. And we have also air quality forecasting system, and this is one of the areas of cooperation with India. Next, please. And then we have fairly heavy infrastructure. We have 200 stations in the country, sounding stations. We have 11 radars. We have satellite receiving facilities. We are also doing measurements in the Baltic Sea, both with fixed monitoring, and also we have gliders, and we are using drones nowadays, and so forth. And we are also some sort of test bench for Vaisala companies' new products. Next, please. And then in Europe, we have joined our forces. We have ECMWF, which is providing the best quality long-range forecasts. We have EUMETSAT. I used to be chairman of the EUMETSAT Council for 2 terms, and I'm representing Finland in IPCC. And in North European Baltic countries, we have created a joint forecasting system. We can transfer the forecasting business between Norway, Finland, and Sweden, because we are running the same system. And we are coordinating the whole European weather radar network in a project called OPERA. Next, please. And weather model development, that's what we are doing as part of the ECMWF community, but we have also the medium range weather forecast. The services are having joint development going on, and this artificial intelligence use is at the moment a hot topic, and we are also allocating more resources for that purpose. Next, please. And we are interested in having higher resolution scales, and our desire is that we would be able to go to 200 meters resolution, which is needed, for example, for hydrological applications, and we are members of ECMWF. Then we have this joint work with Meteo France and about half West European countries, and then we have very strong Nordic cooperation in this field. Next, please. And as I already mentioned, we have a program called EUMETNET in Europe, and there we are coordinating the European weather radar network. Russia was part of that until they attacked Ukraine, and thereafter they stopped the delivery of data for that purpose. And we have 150 radars covering whole Europe. Next, please. And then we have some success factors for our work, and this is how the temperature forecasts have been evolving, and we have been able to reach about 90% accuracy in those, and also in this longer 5-day scale there has been positive evolution, and with artificial intelligence we expect that this will be even further enhanced during the coming years. Next, please. And then we monitor also customer satisfaction. We have plenty of government customers, but we have also paying customers, and we have been able to reach fairly high customer satisfaction level, and we hope that this will be continued also in the future. Next, please. And then concerning atmospheric chemistry, we are hosting a couple of headquarters at FMI, one for air pollutants and aerosols called ACTRIS, and then we have also carbon monitoring network called ICOS, and those headquarters we have been hosting for the past years at FMI. Next, please. And we have our own measurement sites for greenhouse gases, both in Finland. We have one set up in northern Finland in the Arctic environment, and we have also plenty of monitoring going on in southern part of the country, and we have also monitoring in the Baltic Sea, which is a remote island, and our idea is that we cover various ecosystems and understand both the sources and sinks of carbon dioxide, methane, and nitrous oxide. Next, please. And here we have some measurements of examples of our measurements from Lapland. We have the longest time series of carbon dioxide and methane from the Arctic, and we have seen this steady increase of both of them. So far, no positive news, and we don't fully understand why the global methane concentration is growing, and that's one of the scientific questions that we are trying to solve. Next, please. And this is the European carbon network, and perhaps I don't go to details, but we are also monitoring what's happening worldwide based on satellites and ground-based measurements carried out by WMO GOES stations. Next, please. And at WMO we created a new program called Global Greenhouse Gas Watch, and here you can see which are the most important factors contributing to the warming of the climate. This blue area tells about fossil fuel consumption, and that's 2/3 of the problem. The orange color is deforestation of the tropical rainforests in Amazonia region, in Central Africa and Eastern Asia, and about 20% is red color, which is coming from methane, and we have fairly big uncertainties in relationship to role of biosphere as a source and sink of carbon dioxide. And as I already said, this methane increase is not fully understood. Next, please. And this Global Atmosphere Watch program is such that we are combining the data from ground-based stations and satellites, and to better understand the daily behavior of carbon dioxide, methane, and nitrous oxide. And in Finland, our desire is that we will be one of the key players in implementation of that program. Next, please. And then this air pollutant ACTRIS activities, we have measurements also in Finland, but we are also active at Antarctica and various parts of the world, and we have been also active in Russia before they started their attack to Ukraine. Next, please. And then we have also expertise in monitoring what's happening to sulfur dioxide in the ocean area, and here you can see the shipping routes and where the sulfur dioxide emissions are coming from, and this sulfur dioxide is shadowing the whole planet. Without the sulfur dioxide, we would see even higher numbers of warming, and for example, in the Baltic Sea, one is no more allowed to use fuels which are having impact on these gases. That's why the Baltic Sea is nowadays fairly clean. Next, please. And then we are dealing with satellites and space. We have our Arctic Center in Lapland, and there we are monitoring using satellite receiving and processing facilities for Finnish customers, but also for many European customers, US, Canadian, Japanese customers, and this is also an area where we could foresee cooperation with Indian satellite data providers. Next, please. And we can, for example, use satellites for monitoring of the hotspots of fossil carbon, which are the red boxes here. It's Europe, Middle East, Eastern Asia, and both coasts of USA and Southern Africa. And the blue boxes indicate where we have the biggest emissions coming from biosphere, and that's deforestation in Amazonian region in Central Africa and Eastern Asia, especially Indonesia type of regions. Next, please. And then we are also in charge of the atmospheric composition monitoring for EUMETSAT, and there's growing interest to go to greenhouse gases. For example, here's a map of methane emissions. You can see what's happening, for example, in the Siberian wetland areas where we have emissions, and also how the vegetation is behaving when it comes to carbon dioxide sinks. And this is led by us, and we have many European partners in this consortium. Next, please. And also the snow and ice, that's there we are using satellites and of course our forecasting models, and that's also where we have fairly wide European roles, both at EUMETSAT and also European Space Agency, and of course snow and ice. That's very important for our country as well. Next, please. And then science is important for us, and we also produce scientific papers, and that has always been part of our business. Next, please. And we publish about more than 350 papers every year, and last year we almost reached 400 peer-reviewed papers. During the COVID era, our scientists were sitting at home and they had nothing else to do than to publish papers, and that's why we had to get a couple of peaking years there. Next, please. And then one initiative that we created when I was Secretary General of WMO was this early warnings for all. We know that about 100 of WMO members don't have proper early warning services in place, and we have also major gaps in the basic observing systems, especially in Africa, island states, and some Latin American and some Asian countries, and the desire is that we would improve both the basic observing systems as part of this so-called soft program, and also we would help the countries to improve their early warning service capabilities, which is important component of climate adaptation. And so far there has been a couple of billions of dollars mobilized for that purpose, and the desire is that there will be 3 to 5 billion available all in all during the coming years. Next, please. And Finland is also very active in supporting other countries. Here we have ongoing projects with the green dots, and with the blue dots we have a project in the pipeline, and in some projects we are working together with Vaisala company, which is providing meteorological instruments, but in most projects we are working alone, and in many cases we have close coordination with WMO programs in those cases. Next, please. And also air quality is one of the areas where we are cooperating, and we have both Asian and African and other partners where we have been assisting countries to build their air quality networks, the air quality forecasting business, and there's a growing interest also there, and this is of course one important area of our bilateral cooperation with India. It's important that we are able to test our models, how they behave in your environment, and of course we are happy to contribute to the success of your related forecasting business. Next, please. Next, please. And then we monitor also basic weather parameters in our country. And since we are part of the Arctic environment, we have seen more than 3 degrees warming so far, and we have seen an increase of rainfall, especially the winter rainfall amounts have been growing, and that's going to be the future, that we will see more than double the global warming rate, and especially our winters will be more rainy during the coming decades. Next, please. And now I will show you some slides from the most recent WMO reports, where we are with the climate change globally, and we have already exceeded this 1.5 degrees on temporary basis. Last couple of years have been so-called El Niño years, and the previous years were La Niña years, and we expect that during the coming decade we will be more permanently exceeding 1.5, but this is so far temporary increase. There may be years under 1.5, but in 2030s we expect to be there more on permanent basis. Next, please. And we have stored more than 90% of the excess heat to ocean, and this is giving more energy for tropical storms, which means that in your area there's a risk to see more often this category 4 and 5 tropical cyclones, and this is also contributing to the evaporation from the ocean. And our estimation is that there's now 10% more humidity in the air because of the warmer climate, and also because of this enhanced evaporation from the ocean, which is contributing to the flash floods, for example. Next, please. Okay, this seems to not to function. Okay, so there's okay, but anyhow, we have seen an increase of the sea level rise. It used to be about 2 millimeters per year 20 years ago, and recently we have been seeing numbers close to 5 millimeters per year. And this sea level rise, unfortunately, will continue. We don't foresee that it will be ceased. We can seize the improvement, the increase of weather extremes, but in case of melting of glaciers and sea level rise, that may be continued for the coming even millennia. Here is a report from the most recent IPCC report. We have 3 global maps here. The red colors indicate that we have seen an increase of heat waves, and also in your part of the world, that's very obvious that you have seen increase of heat waves. And the green colors indicate that we have seen an increase of flooding cases, and that's also valid for your part of the world. And in the orange color, we indicate where we have seen increase of drought. And some parts of the world, for example, Europe and China, they have been seeing both flooding years and drought years. Next, please. A melting of glaciers, that's enhancing, and the estimation is that by the end of this century, the mass of most mountain glaciers will be severely lost, and that means that we will get less water in many rivers, including some of your main rivers. That's valid also for the Himalayan glaciers, and unless we create means to remove lots of carbon dioxide from the atmosphere, we cannot stop this evolution anymore. Next, please. Again, there's something wrong with the graphics, but there was in the blue area there was supposed to be the temperature scheme, and there's no return back to last century's milder climate, and options are this Paris Agreement 2 to 1.5 degrees warming, and in that case we would be able to seize the negative trend of weather patterns in 2060s, but until then we will see an increase. At the moment we are heading towards 2.5 to 3 degrees warming, which means that we would see this negative trend to continue also for the next century. And in the lower panel we can see what's going to happen to the soil moisture, and all these brown colors indicate the decrease of the soil moisture, and in many parts of the world we have seen a growing amount of brown color, which indicates that we will lose agricultural potential. That's valid for both Americas. It's valid for the Mediterranean region, southern Southern Africa, Eastern Asia, and also Australia, oceanic region. And then it's a question how to feed the growing population of the planet once the conditions for agriculture are going to be worse. But there are some areas where we expect to see increase, and in the central part of Asia and also the Sahel region, we expect to see an increase of the humidity. But as a net effect, we expect to see loss of agricultural capacity. Next, please. And water scarcity and population growth, that's also one of the challenges that we are facing. And here we have overlaid this water scarcity and the population growth, and you can see lots of color in Africa, especially, where the population may be up to 4 billion by the end of this century, besides the current 1 billion. And at the same time, in many parts of Africa, we will see water challenges. Same is true for Middle East and some of your neighboring countries, especially Pakistan, but also in your country, this is going to be a challenge already for the coming decades. Next, please. Oh, that's a pity that we have lost some of the. Here is supposed to be the report of World Economic Forum, where they estimate which are the biggest risk for the global economy, and the biggest risk for the coming decade is the increase of weather extremes, and number two has been this overall climate change. So it's not only a matter of comfort, but it's also an issue that will have a negative impact on global economy. And finally, I would like to show how are we proceeding with the climate mitigation. And here is the challenge in general. All the energy that we use on the planet for energy production, for industry, for transport, and various means, it's more than 80% based on fossil energy, and the consumption of oil and gas has been still growing. There has been a phase out of the coal consumption, and we produce only about 15% of the energy based on climate-friendly means, nuclear, hydro, and renewables. And to be successful in climate mitigation, we should revert those numbers during the coming decades. Next, please. Okay, so this is unfortunately some of the.
Escape that one, original PPT, self-presentation.
I don't know why.
Particular slide is there.
Okay, fine.
Why it is?
I don't know why the.
Now you project. No, that slide. That's.
Okay. So we got it. So we have a high level technical expertise in here, not only administrative one. So this is I'm like happy that we can see the slides. So this is showing where the emissions have been coming from for the past 170 years, and you can see that North America is number one in consumption of both fossil energy, which is the green area here, and the gray is showing how much deforestation has contributed to the emissions, and Europe has been number two, and Eastern Asia go to the previous, and Eastern Asia has been number three, and in some parts of the world, like in Caribbean area and Latin America, deforestation has had the most contribution, but this is demonstrating where we have also challenges. And international shipping and aviation, cross-boundary shipping and aviation, that's only 2% of the problem. Although we are very much talking about the negative impacts of aviation, so that's not, and shipping is not the major problem we have. The major problem lies in the consumption of fossil fuels in other fields. Next, please. And we have seen a decrease of the emissions already in many countries. It's mainly European countries, but also USA, Singapore, and Japan belong to this category. in all of those countries, the economy has been growing. The blue colors indicate decrease of emissions, and red colors indicate economic growth. For example, Singapore has more than almost doubled their economy, and at the same time, about 20% reduction of their emission has been taking place. So we can enhance the economy without enhancing the emissions. So that's positive news. Next, please. And what is positive is that the prices of solar and wind energy, they have been dropping under the prices of fossil energy, and that's why it's very attractive for many investors to invest in solar and wind energy. But besides that, we need also energy sources like nuclear energy and hydropower. And also the prices of electric vehicles and batteries are constantly dropping, and in many parts of the world there's a fairly dramatic growth in use of electric vehicles, and China has become number one producer of such means, and also they are leading manufacturers of solar and wind energy means. Next, please. In Europe, we have planned to become carbon neutral by 2050, and here you can see what are the big sectors of emissions: power production, transport, and industry are the three big sectors, and there we expect to see a drop of emissions, and it's already taking place. And in agriculture, we will still have emissions in 2050, and some of that can be compensated with the carbon sink to forests, which is the dashed area in the bottom. And so far in Europe, we don't believe in these carbon removal technologies in a large scale, which is the lowest, most red dashed area. Next, please. And then it's a question how to solve this problem, and the key issue is to stop use of fossil fuels. Firstly, coal, thereafter oil and natural gas. That's 2/3 of the problem. And the second biggest problem is related to methane, whereas the lifetime of methane is only 11 years. So it's basically an easier problem than as compared to carbon dioxide, where the removal is taking even thousands of years. And this deforestation is also one of the challenges, and Amazonia region, Central Africa, and Southeastern Asia are those hotspots from those perspectives. Next, please. And we have to get especially the G20 countries on board to be successful in this effort, because 80% of the global emissions are coming from G20 countries, and in Glasgow, the G7 countries, the richest countries, made already these 1.5 degrees commitments, but the rest of the G20 didn't. And what's going to happen in China, India, Brazil, South Africa, Russia type of countries, that's going to be key whether we will be able to reach the Paris 2 degrees. I'm personally slightly optimistic that 2 degrees is still doable, but 1.5 may be gone. Next, please. And of course, we as consumers, we can make choices how we commute, what kind of diet we are having. In India, you are in a good position because you are so much vegetarian here, and that's a good example for the rest of the world. In our type of country, how we heat our premises with geothermal means, for example, and how much we consume goods which are produced with fossil energy. Next, please. And finally, a couple of these kind of geopolitical slides. This is also a security issue, and this global food security is one of the big issues concerning climate change. We expect to lose food production capacity, and especially Africa is going to be a very challenging continent, where the basis of the economy is very much agriculture, and the population growth combined is a challenge. And if we are successful with climate mitigation, then some countries like Russia and Middle East countries and even Norway might face major economic problems. The Arctic is becoming more and more a hotspot because of the melting of the sea ice. We expect to see ice-free Arctic in 2040s, and there's growing interest among several countries. China is already fairly well established there, and we have just learned that also India is also has growing interest to be one of the players there. And what's going to happen to the world economy? The slide didn't show up too well, was demonstrating that in the 2030s we expect that there will be growing negative impact of climate change on world economy, and there are some regions which are especially vulnerable, and the Mediterranean region is one of those globally. Next, please. And finally, what kind of impacts you can expect to see here in India? Sea level rise, which we can unfortunately no more stop. We expect to see at least half meter to 1 meter per century increase of sea level rise. It may be even higher if the Antarctic melting takes place in a speedier manner, and you have plenty of. Oh. We go to the previous slide. That one. Yeah, no, the previous one. That one, yes, and put it in presentation mode. So this that's one of your challenges, and NASA has demonstrated there's even a risk of 10 meters sea level rise by 2300, but that's a question whether the Antarctic melting, what is the speed of Antarctic melting. And this melting of the Himalayan glaciers, as I said, most of the mass will be lost by the end of this century, and that means that you will get less water in some of your main rivers, which will have impacts on food security and human well-being. Warming of the ocean, that contributes to the tropical storms. Risk of flooding, drought, and heat waves is increasing. And as we all know, you have also major challenges with air quality, and you could find a win-win by solving the air quality and climate challenge at the same time. And carbon tolls, they are prepared by, for example, they are under preparation by European Union at the moment, and that may be also affecting fossil energy-based businesses. Next, please. And this is my final slide. In the most recent IPCC report, they were demonstrating that we will have combined negative impact of higher temperatures and more humidity, and at least parts of your country is very sensitive to that. I was yesterday in Chennai, and I was feeling this humidity and high temperatures, and in summertime it's even more, and that's going to have a negative impact on the working capacity of individuals if you are not able to use air conditioning, and the higher the warming rate is going to be, the wider area globally we will have more days every year with this combined negative impact of high temperatures and humidity. Next, please. That was all. So thanks a lot for the opportunity to address you, and it was a little bit long presentation, but hopefully it was interesting from your perspective. Thank you.
So we can take a few questions, and those who are online may please raise their hand or put their questions in chat box. So when Rekha Dikshit, I think she want to ask some question. Rekha.
Introduce and.
Yes, my name is Rekha Dikshit, and I write for IIT Madras's Shastra magazine, which is a science magazine. So, in your presentation, you were showing about the rate at which the glaciers are melting, and over that 100 or 150-year period, you have shown 2 or 3 years in which actually the glaciers have not melted. If you could go back to that slide and explain exactly the reason that could have been so.
2 of the glaciers not melted.
2-3 years.
2-3 years. No.
So we have seen, of course. Go forward. So that now you're going backwards.
To come out from this PPT and go on.
It's the one with the red bars downstairs. That one, yes.
Yeah, that's the one. Yes.
So we have seen also this kind of variability in global temperatures, and some of those years are related to the volcanic eruptions when we had a little bit cooling effect of this El Chichón and Pinatubo, and that may have had an impact. But we have also this natural variability, which you can see from year to year. So it's not linear, but the trend is quite obvious, and it's quite alarming, I would say. And we will have a United Nations glacier conference in Tajikistan in late May, where I was invited to be one of the key speakers, and also preparation of the final document coming out of the meeting. And in Central Asia, for example, 65% of the freshwater resources are coming from the glaciers of Tajikistan, and since most of those will be gone by the end of this century, it's going to be a major water disaster for all of those Central Asian states, and also in your case, what's going to happen to some of your rivers? That's going to be a big issue.
So you're saying that some volcanic activity actually caused more glaciers or less melting of glaciers?
So we have seen a couple of cooling years. For example, this Pinatubo led to a global cooling impact in 91 to 92, and this El Chichón was having impact in the early 80s. But we have also this natural variability here.
Thank you, sir.
Regarding North America and South America, if you see, that because of global warming, precipitation has decreased, and it is also showing significant soil moisture decrease. So which will cause actually impact on agriculture. And already you are seeing that there is energy consumption is large in this part of that. So naturally now more energy consumption will be there because for agriculture purpose itself, and because of temperature increase. And at the same time, the country America, they say that we are not going to now listen to what is the climate action. We will going to use more fossil. Already they are high. So what do you think that how the future will be? So
yeah,
and we have got a target of keeping 1.5. It's a geopolitical question.
Yeah, but I'm happy to answer that because in the last era of Trump, there were similar stories, but despite of that, the US emissions were dropping because it's attractive to invest in solar and wind energy, and because the prices are more attractive for the investors, and also this use of electric vehicles was growing, and in many places, many states of USA, they have fairly ambitious climate programs, and the government cannot hit those. So we expect that this climate mitigation will continue in states also during the coming 4 years, but USA won't be so active at the United Nations climate negotiations, which is of course a negative thing. And it's a question whether there's space for more fossil products globally. My guess is that that's not the case. If USA would like to sell more, I think that we already have been able to reach some sort of status where we are not consuming more fossil sources of energy, and that would only lower the prices. And so I think that that's not very realistic. But this negative tone against climate action, that has been, there's been this kind of variability in some of the Anglo-American democracies. It has been same for Australia, for Canada, and USA, depending on the government. There's been more progress in climate mitigation and less progress, but I'm confident that there will be progress because of investors in USA, because of individual states. But of course, the political environment globally is not so favorable. So if we would be in a position to sign the Paris Agreement today, we wouldn't get the support of US president's administration, and thanks to the previous governments, we were able to sign the Paris Agreement when USA, China, and European Union were having the same position. But it's a slight slashback, but it's not going to be a catastrophe, I would say.
Yeah, you have shown that this GDP growth is more and more decoupled from the emissions. So is it because more increase in the cleaner energy or availability of cleaner energy, or something else?
So especially in European countries, we have already stopped using more and more this fossil fuels. It's very little coal is consumed nowadays, and because of this Russian aggression in Ukraine, there's been also a decrease of the consumption of gas, and at the same time there are new type of businesses which are not so dependent on consumption of high volumes of energy. So that's for example, IT industry and service businesses don't demand so much energy, but it's this energy transition plus new types of businesses. For example, in Singapore, they are not big manufacturer, but they have different types of businesses, like headquarters of big companies and banking sector and so forth. And for such businesses, you don't need large amounts of energy.
So any question from? We can take a few more questions here, and then.
Chat box. Slide, one of the slide, only one some part of India is shown in white color, like Jammu Kashmir and that slide. So we are seeing only finding for our all parts, including Jammu Kashmir and Arunachal Pradesh also. So, but in your slide, it's shown by white color.
So this was based on the WMO service, and we were asking the members how is the status, and it was according to information that we were receiving, and some countries didn't report, and so some countries were reporting. It was not justified whether the information that they provided was correct. But we have also means like, for example, ECMWF is cataloging how much of the stations are reporting, how much of the data that we are getting from existing stations, and there we get much better information. But this was based on the reporting of the countries, and it's important that we have criteria for individual countries when it comes to observation systems, and we have also criteria for individual countries when it comes to their service capabilities. And the WMO Service Commission is going to meet during the coming weeks, and they are trying to set standards for the early warning services. It's important to classify the early warning services so that we can say, once we have been able to reach a minimum standard of early warning services, that's needed to say when in individual countries, I would say early warning service compliant.
I have one quick question. Of course, in European Union, you have various observing system and other things. So how do you define any optimal design is required for observing system? Have you designed anything?
Yeah.
Suppose, for example, radars, 100 radars. So you have come out with some optimum number. You have made it like that?
Yeah. So in Europe, we have a program called HuMetNet, which is very much devoted to the joint operation of the observing networks, and they have been setting standards and recommendations where we need to enhance the amount of observations, and there we have already fairly dense network of observations. When it comes to weather radar operations, it's a little bit philosophical question. For example, Germany is having almost 30 radars, and their philosophy is that they can have radars which are not operational, and that's affecting the maintenance of the radars. In Finland, we expect that the radars should be operational something like 90 to 95% of the time, and we don't have we don't have too much this kind of overlaying radar schemes, and in Germany they have, and there they can rely, they can be satisfied with 70% of the operationality of the radars. So that's but in most countries it's just coverage, and they're doing the at most that the operating rates would be fairly high, and that's we are reaching one of the highest in the world when it comes to operational rate of the radars.
So let us thank Professor Petteri Taalas for this very informative talk, and now it's time for us to express our gratitude to Professor Petteri Taalas. I would request our DGM to kindly present a shawl and a memento to. Yeah. Yeah.
Congratulations for IMD for the 150th anniversary, and it's a great achievement. We are even slightly older. Yes. Yes. Senior, I'm happy to congratulate.
Yes. Yes.
I would also request DGM to please felicitate Dr. Antti and Dr. Rakesh by presenting a memento.
Right? Yeah. No. You have got some.
There is another one. Okay. He missed in the previous session, basically.
Careful. Yeah.
Yeah, Dr. Rakesh. Dr. Rakesh is the principal scientist in Finnish Meteorological Institute, although he's from Delhi only.
So besides being an excellent scientist, he's been very much the person behind our fruitful cooperation between India and Finland.
It's an honor for me to present the vote of thanks. We from on behalf of India Meteorological Department express our gratitude and thanks to Professor Petteri Taalas for kindly sparing the time and delivering this very informative lecture. We are also thankful to Secretary, Ministry of Arts Sciences for kindly sparing the time with us despite of his very busy schedule. We thank our DGM under whom we are organizing this series of lecture and other successfully organized this 150-year programs. Thanks to all my colleagues that right now all our division heads of different divisions are here. So thank you all, and there are many participants of the lecture joined online from our different regional meteorological centers, and other institutions in India. So we are also thankful to all the participants of this lecture. Thank you all. Thank you very much.